All right, ladies and gentlemen, this next section is talking about macromolecules. So if you'll remember, the word micro in microscope means small. Your macro is just the opposite of that, which means large. So this literally means large molecules. So there are only 4 major types of macromolecules that we have in our bodies, and our 4 different types are your carbohydrates that we call carbs. We have lipids, we have proteins, and we have nucleic acids. So out of these 4, you probably will have heard in some form or fashion the top 3, because you can find all of these things discussed when we talked about food. So a lot of times people say, I'm going on a low carb diet, or I'm going on a protein and carb only diet. They're actually talking about these large molecules that are going into their food, going into their bodies. So whenever we talk about humans and how we get our energy, how we get the stuff needed to build us so we can grow, we are talking about these 4 major types of macromolecules. So let's talk about these 4 macromolecules in detail. You are going to have to know for me, for each one, what are the elements that they contain, kind of what they look like, so a little bit about structure, including monomers, and their functions. So what do they do? Okay, so what all 4 have in common, the thing that all 4 of these have in common is that these are all polymers. So these are all polymers. What is a polymer? A polymer is just a large thing that is composed, that is made up of many units. So made of many units. Now, when we talk about these units, we're talking about one building block. So like how if you were to build a tower out of, or build a house maybe, you will be building them, hopefully, out of some building block. So like a house is made out of all of your bricks, right? You take your bricks and then you build your house. Each one of these is a building block. So your house in this case would be the polymer, and each individual one of these is a building block, aka how we call it in biology, a monomer. If you'll remember a couple of your word parts, mono just means one, and poly means many. So it's kind of fitting because one brick is one monomer, one building block, and your polymer is made out of many units, many building blocks. Okay, so all of these 4 up here are all polymers. They're all made out of many units that are repeating, right? You repeat the bricks over and over again to make your house. In our case, for our biomolecules, a lot of these are going to be just one line, just one chain, or branches of them, but for our purposes, let's consider them one chain. So each one of your chains, each chain is your polymer, and each one here is a monomer. Monomer plus monomer plus monomer and plus monomer. When you have multiple monomers, this becomes a polymer. Again, poly, many, mono meaning one. Okay, so all of these four carbs, lipids, proteins, nucleic acids kind of look like this chain. kind of look like this chain. Now let's talk a little bit about how they are built. So when we're talking about building these macromolecules, we want to take one monomer plus another monomer to give us the chain of monomer, right? We join them together, monomer 1 plus monomer 2. Now you are joining these to make one molecule. So this reaction, when you're building this macromolecule, this polymer, this is called dehydration synthesis. Another clue about word stuff is that synthesis here just means to make. Just means to make. And dehydrate, remember, means to remove water. In this case, we're actually producing water. We're making water out of this whole situation. How this actually works is on this end, right here on this end, we have an H, and on this end we have an OH. So this is already part of your building blocks, part of your building blocks. So if you'll notice that when you put H and OH together, this is going to give you H2O because you have 2 hydrogens and only 1 oxygen, and H2O is water. So in order to make this bond, right here, you need to open up the space. You need to make space for them to join, and to do that, you take this water and you remove it. So your water is actually going to come out. One H2O is going to come out so that you can make this. This is why we're calling it dehydration synthesis, because you're removing water from these 2 molecules to join them together. Okay, well, if building is dehydration synthesis, where you're making one big molecule, then to break this big molecule, going from when they're joined together into the 2 parts, going from a polymer to 2 monomers here, we are going to be breaking this bond. Remember, here is a bond. We're going to be breaking this bond, and this process is going to be called hydrolysis. Hydrolysis. Again, hydro meaning water, and lysis meaning break or to split. I like slice a lot because it sounds like lysis. So this is water slicing or cutting open your polymers. So what you're going to do with your water is going to come back. Your water is going to come back. It's going to come in here and it's going to break this bond. It's going to break this bond so that this, your O's and H's are going to go back onto the 2 monomers that it came from. So if you'll notice that building your monomers is the exact opposite as breaking your polymers. Building polymers, exact opposite of breaking polymers. So this is the essence of how you make and break your macromolecules. This is the same process going on for all 4 of your macromolecules. And we'll talk about that in the next section.